Welcome to Dedupe version 2.0. Dedupe is a novel tool for interactive data deduplication and integration. It is especially well suited for deduplication of relational data, such as social network and communication data, and other graph data. In this tutorial, we will give you a demonstration of how to use Dedupe for entity resolution in relational data. The dataset that we will use for this demo is the bibliographic dataset from the ACM Digital Library. The dataset contains about 4,100 papers published in the ACM CHI conference over 20 years. It describes the work of 6,300 authors and consists of 12,000 co-author relationships among the authors. While the dataset has been hand-cleaned, as we will see, the dataset still contains many duplicates which may pose data integration challenges. This is the overall Dedupe user interface, which is composed of three coordinated windows: the Potential Duplicate Viewer, the Relational Context Viewer, and the Data Detail Viewer. The Potential Duplicate Viewer is on the left and shows a list of potential duplicate author pairs that are identified based on the user-defined similarity metrics. The second viewer, the Relational Context Viewer, is in the center and shows a node-link diagram which visualizes the relationship between the potential duplicate authors. Finally, the Data Detail Viewer is on the bottom right and shows all the attribute values of the nodes and the edges displayed in a Relational Context Viewer. Let's load the bibliographic dataset using the Open Main menu. Once the dataset is loaded, the Similarity Metrics tab in the search panel shows all the attributes of the node entity. In this example, these are author attributes such as first name, last name, affiliation, and so on. In this tab, I'm going to choose the author's full name and affiliation and apply the Jaro-Winkler and the Jaro Similarity Measure function respectively for computing the author similarity. And I'm going to give more priority to the full name by assigning more weight here. After the similarity metric is defined, I can have Dedupe search for the potential duplicate authors by pressing the search button. Before starting a search, I can choose different search strategies or specify the number of potential duplicate author pairs to be displayed in the list. The search process can be stopped at any time by pressing the stop button. Then Dedupe shows only the partial search results found before the process is stopped. The potential duplicate pairs are sorted by their similarity values. Once the potential duplicates have been identified, I can select a duplicate pair in the list to observe their relationship in the Relational Context Viewer. In this example, the nodes represent the authors, and the edges between the nodes represent the papers co-authored by those authors. The thickness of the edge represents the number of co-authored pairs. The potential duplicate authors are represented as squares and placed in the middle of the screen. The shared co-authors of these duplicates are placed in between them, and the non-shared co-authors are placed on either side. By default, only the edges between the potential duplicates and their co-authors are shown, and the edges among the co-authors are hidden. However, all the edges can also be displayed by checking the Show All Edges checkbox located on the toolbar. With this simple, stable, and meaningful layout, users can easily recognize the shared relational context between the potential duplicate authors. In the Relational Context Viewer, nodes can be resized by the number of co-authors or by the number of papers each author has written. The nodes can also be sorted by their attributes such as name, node size, and edge size. Nodes can also be filtered by the size or the thickness of their edges. While in this example there are two shared co-authors, there may be additional unidentified shared co-authors among the neighbors. Users can adjust the similarity threshold in the toolbar to identify the potential duplicates in the non-shared co-authors. The Data Detail Viewer shows the attribute values of the authors and the papers that are displayed in the Relational Context Viewer. The Detailed Data Viewer is composed of three subpanels: the Potential Duplicate Viewer, the Node Viewer, and the Edge Viewer. The Data Detail Viewer and the Relational Context Viewer are tightly coupled. For example, if I select these nodes, the corresponding records are highlighted in the Node Viewer. Similarly, if I select an edge containing two authors, all the papers co-authored by the authors are highlighted in the Edge Viewer. On the other hand, if I select a paper from the Edge Viewer, all the edges connecting the authors of the selected paper are highlighted. I can search for more details about authors or papers online. For example, if I double-click an author in the Node Viewer, Dedupe will automatically query Google Scholar for this author. Users can merge the duplicate authors using the Merge button in the Potential Duplicate Viewer. If I press the button, the Merge dialog pops up. The dialog shows all the attributes of authors in the first column and the corresponding attribute values of the potential duplicate authors in the next two columns. The last column shows the attribute values of the author that will be created by merging the potential duplicate authors. I can either pick values from the duplicate cell or type in a new value. Now I can merge them by pressing the Merge button. Once the duplicate authors are merged, Dedupe automatically searches for the next potential duplicate author of the merged author, so that users can continue resolving the same author. If the potential duplicate authors are not actual duplicates, users can mark them as distinct using the Mark Distinct button. Then the marked pairs are automatically excluded from the search results. Users can explore the merging history of an author using the Node Lineage dialog. The Tree View tab shows the merging hierarchy of the duplicate authors along with their prior attribute values. Alternatively, the Graph View shows an ego network with the selected author in the center and all its co-authors in a concentric circle. By double-clicking the center node, users can see how the prior duplicate authors used to be connected to the current co-authors. On the other hand, if the user has made an incorrect decision, they can return to the tree view and restore authors to their distinct view by splitting them. This has been a quick tour of Dedupe. Dedupe can be used with any data described as a single mode or two-mode relational database. It is easily extendable with domain-specific similarity measures and is easy to embed calls to external programs to gather additional information in the data detail viewers. There are many additional features which have not been described fully. If you would like more information, please visit our website at www.cs.umd.edu/linqs/